See, in thermodynamics, we studied about cycle. Now, before I explain you about IC engine, two-stroke, four-stroke engine, I want to give you only small basic idea of cycle. Because I don't have so much time now, in future I will post a video where I will explain you about in detail about cycle. But today only I am giving you basic idea about cycle. What do you mean by cycle? Cycle means when it starts from a particular state and after a particular period of time, when it finishes, it returns back to the initial state. That is known as cycle. What is the meaning of cycle? Cycle means when you are starting a process. Okay, just to see this example, it will be more clear if you see this example. If you are starting a process and before you starting a process, suppose this is a one from here, suppose you are starting from here, this one. So when you are starting from one, okay, as you are starting from one, so after one there will be processes taking place. Okay, from 1 to 2, 2 to 3, 3 to 4, again it is coming back to 1. See, from 1 it's starting, so it is going 1 to 2, then it is going 2 to 3, then it is going 3 to 4, then it is coming back to 1. So what is it is starting from a state. State means a point in this cycle. From 1 it is starting, from 1 it is going to 2, from 2 to it is going to 3, so 3 to 4, again 4 to 1. So 1 to 2 is one process, 2 to 3 is one process, 3 to 4 is one process, and 4 to 1 is a process. So what is that? Several process takes place which are interrelated to each other, and after process finish it comes back to the original state. That is known as cycle. Cycle is very simple. If a process starts, suppose from 1 you are starting a process, from 1 it is going to 2, from 2 to it is going to 3, from 3 to it is 4, again it back to 4 to 1. These are all process. 1 to 2 is one process, 2 to 3 is one process, 3 to 4 is one process, 4 to 1 is one process. So all the processes which are taking place, and finally when it comes back to the original state, that is known as cycle. Okay, so why we draw a cycle? In an IC engine we draw year standard cycle. Why we draw year standard cycle? Because we want to analyze the IC engine theoretically or hypothetically. Hypothetically means imagine it in a theoretically. For theoretical calculation, to find out the work done, we draw a cycle. Cycle is purely hypothetical. Purely hypothetical means purely imagination. Why we draw a cycle? We draw a cycle so that we can calculate or analyze the work done theoretically. See, suppose this is a cycle 1 to 2, 2 to 3, 2, 3 to 4, 4 to 1. So the area inside the cycle, this area 1 to 2 inside this cycle 1, 2, 3, 4. Okay, this is 1, this is 1 point, this is 2 point, this is 3 point, this is 4 point. So 1, 2, 3 and 4. So this area inside this cycle 1, 2, 3, 4, the area which is there, that area is showing work done. What is the area inside the cycle shows? It shows the work done. Why we draw a cycle? We draw a cycle to analyze the performance of IC engine theoretically for calculation. Suppose in paper you have solved maths in your childhood age. Okay, like that we want to calculate or find out the performance like work, heat transfer theoretically, like a mathematics which you solve in board. Because by looking at that performance, we can improve the IC engine performance practically. So the performance of cycle can never be equal to the performance of a IC engine. Practically, IC engine will show less performance. Practically, IC engine work will be less. Why practically it will be less? Because in cycle, we are thinking there are no losses internally. What is there? Why we are assuming? We are assuming cycle is there is no losses internally. What losses? Losses like due to friction, heat losses from the inside the system to the surrounding, or from the surrounding to inside the system. System means what? Suppose I am catching this, anything. So if you are the thing which I am concentrating, that is a system. So suppose I am looking at the mobile charger. So mobile charger is the system, and surrounding, I am the surrounding, my room is surrounding, same thing. The cylinder is the system. So if the cylinder is the system, there will be inside the system, it's inside the cylinder. Cylinder, where combustion takes place in IC engine, inside the cylinder. Inside the cylinder, if the cylinder is the system, there will be no losses. There will be no losses taking place. What losses? Friction. Suppose piston is moving up and down, so there will be no friction. No heat will come from outside to inside the system, or from the inside the system to the outside. No heat losses will take place. So that is internally reversible. We are assuming the cycle is internally reversible. By assuming the cycle as internally reversible, we are calculating the work done in an IC engine. So my few questions, I'm to make clear your basic idea, I'm discussing question along with answer. Why we draw a cycle? To analyze IC engine theoretically. Why we want to analyze IC engine theoretically? Because we can improve the performance of IC engine practically. That's why we want, by looking at the theoretical analysis. What is the area inside the circle denote? The area inside the circle denotes work done. Okay. So what are the assumptions we take inside the cycle? Inside the IC engine cycle, for IC engine we draw year standard cycle. What cycle we draw? Year standard cycle. In that year standard cycle, we draw Otto cycle, diesel cycle. So Otto cycle is drawn for petrol engine, diesel cycle is drawn for diesel engine. What cycle is drawn for petrol engine? Otto cycle. What cycle is drawn for diesel engine? Diesel cycle. And another cycle is high speed diesel engine. For that we draw dual cycle. So there are three cycles which we normally use to analyze IC engine. What are the cycle? Otto cycle, diesel cycle and dual cycle. Otto cycle we draw for petrol engine. Diesel cycle we draw for diesel engine. Dual cycle we draw for high speed diesel engine. So Otto cycle we are drawing for this diagram which I am showing for Otto cycle. Another video I will explain in detail in future. I will post a video there. I will be explaining in detail about cycle. So first I want to tell you why we draw a cycle to analyze IC engine. So what is the area inside the cycle shows? It shows the work done. Okay. So the area inside the cycle is showing us work done. And what are the assumptions we are taking in year standard cycle? Year standard cycle means the cycle which we draw for IC engine analysis. What are the assumptions? We are thinking only year is used as working fluid. Practically what is used? Practically the IC engines of a bike, scooter, car, truck, whatever you run, we use either petrol and air or diesel and air. Either we burn petrol and air or we burn diesel and air. So, but theoretically we are assuming only air as the working fluid. Why we assume air as the working fluid? Because air is air is compressible. People may ask you the air standard cycle, why they assumed only air? Why they not assume liquid? Why they make the name air standard cycle? Because we make air as the working fluid. For IC engine we draw air standard cycle. Why we draw air standard cycle? Because air is only the working fluid which we are assuming. Why they assume air as the working fluid only? Why they don't assume liquid? Because air is compressible, but liquid is incompressible. Liquid, see, in IC engine we draw air standard cycle. Everybody knows air is there, liquid is there. So in earth mostly for human survival, liquid and air is very much essential. So please remember, in an IC engine, it's not water. In an IC engine, petrol is used in petrol engine and diesel is used in diesel engine. So petrol and air mixture, diesel and air mixtures are there. Okay. So if in an IC engine we are using petrol and air mixture or we are using diesel and air mixture, why we are assuming air as the working fluid? If for assuming hypothetically assumption of air standard cycle, because air is compressible, liquid is incompressible, means we cannot compress liquid. If Lord Brahma come and use Brahmastra also, he cannot compress liquid. Could you understand? Lord Brahma or Indra, they've used Indra Astra, then also he cannot compress liquid so easily. So liquid is incompressible. Air is compressible. That's why we assume air as the working fluid, and that's why they make the name air standard cycle. Why they make the air name air standard cycle? Because air is assumed as working fluid. What is the area inside the circle denotes? It denotes the work done. Now, what are the things we analyze? Practically, first I am speaking, practically in petrol engine and diesel engine, what is happening? Chemical reaction takes place. Practically in petrol engine or diesel engine, chemical reaction is taking place. Chemical reaction takes place practically in petrol engine and diesel engine. But theoretically in air standard cycle, we are thinking, we are taking air, okay, we are taking air from high temperature reservoir, we are taking heat and we are rejecting heat from to low temperature reservoir. Okay, like this we are assuming. See, from high temperature reservoir we are taking heat and we are rejecting heat to low temperature reservoir. See, now from here in outside the system, heat goes to low temperature reservoir. Okay, so practically what we are thinking, we are taking heat from high temperature reservoir. See, here this is high temperature reservoir. From here we are taking heat. Okay, we are taking heat in the system and we are rejecting heat to the low temperature reservoir. We are rejecting heat. But this is the thing which we are thinking, which we are analyzing, or we are thinking like this. These are purely theoretical. Practically what it happens, chemical reaction takes place. Due to the chemical reaction, heat is generated and combustion takes place. But theoretically what we are thinking, we are taking heat from high temperature reservoir and we are rejecting heat to low temperature reservoir. So this is high temperature reservoir. From here we are thermal reservoir, either you say high temperature reservoir or thermal reservoir. From here we are taking heat at temperature T1 to the system, and from the system we are rejecting heat at temperature T2. So this is rejecting heat. Okay, so from here we are taking, and from high temperature reservoir we are taking the heat and we are rejecting heat to low temperature reservoir. But practically what happens? Practically chemical reaction takes place. Due to chemical reactions, lots of heat is generated. This happens practically. But theoretically what we are assuming? We are assuming there is a high temperature reservoir. From high temperature reservoir we are taking heat from inside the system and we are rejecting heat in the low temperature reservoir. This is the thing which we are thinking theoretically. So theoretical and practically are both totally different. But why what is the thing is that for analysis purpose, because why we are thinking theoretical like this, because inside the cylinder it is very difficult to know how chemical reaction takes place. When anything burns, it's very difficult because we cannot see combustion inside the engine cylinder. That's why they have thought theoretically to calculate, we have to analyze in this way. What we will do, we will think there is a high temperature reservoir, from there we are taking heat inside the system, and inside the system there is no losses taking place and we are rejecting heat to the low temperatures. Okay, so please remember, inside the system there is no losses takes place. In air standard cycle is internally reversible. What is internally reversible? Like Otto cycle, diesel cycle, dual cycle, all those cycles are internally reversible. What is the meaning of internally reversible? The meaning of internally reversible means there is no losses taking place inside the system. Inside the system means, suppose inside the cylinder there will be no friction or there will be no heat coming from the outside to inside the cylinder, or there will be no leakages of heat from inside the cylinder to outside to the atmosphere. So these are the things which we are thinking. Okay, so practical and theoretical is different. Why we are thinking in this way? Because it is, see, when anything combustion is taking place, it is very difficult to see inside what is happening inside. Can we see when we are riding bike or car? Can we see inside how combustion is taking place? No, we cannot see. So for that we have to analyze. So for the analysis purpose, we are doing analysis by this basis. Now, there are, now let us come to the strokes. Okay, what is happening? There are four strokes in four. In now I will explain you two stroke and four stroke engines. In four stroke engine, four time piston moves up and down. How many times piston moves up and down? Four times. In two stroke engine, two time piston moves up and down. In two stroke engine, how many times piston moves and down? Two time. In four stroke engine, crankshaft rotates two time. In two-stroke engine, crankshaft rotates only one time. Please listen again. In four-stroke engine, four time piston moves and up and down. Up and down. Suppose I'm in front, there is a staircase. From bottom of the staircase, I am staying in fourth floor. My college where I am teaching. Suppose my room is there in fourth floor. So to go fourth floor, I am going four times. One time I am going up. Again from fourth floor I am coming down. Again I am going up. Again from fourth floor I am coming down. Again I am going up. Again I am coming down from fourth floor. Again I am going up. Again I am coming from out from fourth floor. So four times I am going up and down in four stroke engine. Same thing, four stroke engine, piston moves four times up and down. Okay, in two stroke engine, same thing. Suppose I am going in fourth floor. Okay, sitting. Again I am coming down. Again I am going in fourth floor. Again I am coming down. So two times when I am going up and down, same way when piston moves, goes up and down, two times, one time it goes up, one time it comes down. So like this two times when piston moves, that is two stroke. Two stroke, how many times piston moves up and down? Two times. Two times means one time it goes up, one time it comes down. That's all. Four stroke, how many times piston moves up and down? Four times. One time it goes up, one time it goes down, comes down. Again it goes up, again it comes down. Okay, so don't get confused. In two stroke engine, two time piston moves up and down, and four stroke engine, four time. Means two time it is finishing everything. One four stroke engine, four time I am going up in the staircase and coming down. But in two stroke engines, one time I am going up in the staircase and one time I am coming down. This is simple, very simple. How many times crankshaft rotates in four stroke engine? Two times. How many times crankshaft rotates in two stroke engine? One time. Okay, so to best you explain, I gave you very good example that going up in the staircase and coming down in the staircase. Suppose the staircase are there on top. Another examples I am giving you. Okay, suppose I am throwing anything on top. Okay, and catching ball. So when I am throwing the ball up and the same ball goes up and again it comes down in my hand, then that is two stroke. Same ball, if I four times I am throwing it up, it is going up, it is coming down, again going up, again going down, then it is four stroke. So if you throw the ball up, what will happen? The ball will go up in the sky and you will catch it. In your childhood age, you might have played cricket. Most of the Indians play cricket. Even suppose some of them, some Western countries play football. Okay. So what I am telling you, so when suppose football, you are throwing it up, okay, and you are catching the football. So that is two stroke. So it is going up one time and coming down one time. So you are catching it. That is two stroke. Same football, if you goes four times up and down, one time goes up, one time go down, again you kick the football, again football goes up, again it comes down. So it four times it is moving up and down. That is four stroke. So two times when anything moves up and down, that is two stroke. Four times means two times means one time up, one time down. This is two stroke. And one time up, one time down, one time up, one time down. So this is four stroke. Four stroke, four time piston will move up and down. So what now let us explain you the strokes. So I explained you two stroke and four stroke. Okay. Now you should understand in four stroke what are the strokes which are taking place. What is the meaning of stroke? Stroke means up and down motion of the piston. Very simple explanation. What is the meaning of stroke? Stroke means up and down motion of the piston. So stroke means suppose one time I am going up, that is one stroke. So stroke means up and down of the piston. Simple. So when the piston moves up and down, that is stroke. Two stroke means one time up, one time down. So two. So two time up and down. Four means one time up, one time down, one time up, one time down. Then four. So in two times extra up and down the piston does in 4-stroke, and 1 time extra rotation of crankshaft takes place. In 2-stroke only 1 time crankshaft rotates. In 4-stroke 2 time crankshaft rotates. Okay. Now this is a suction. Now let us explain you the strokes in IC engine. Suction stroke. Suction stroke means what? Piston is moving from top to down. When the piston moves from top to down, that is suction stroke. In suction stroke, inlet valve opens, fresh air comes inside. I am explaining you now 4-stroke engine. First stroke is suction stroke. For suction stroke, what is happening? Inlet valve open, exhaust valve close. What is happening in suction stroke? Inlet valve is open, exhaust valve is closed, and piston is coming from up to down. This is suction stroke. See, piston is moving down, inlet valve is open, exhaust valve is closed. This is suction stroke. Okay, this is suction stroke. What is happening in suction stroke? Inlet valve is opening, exhaust valve is closed, and piston is coming from up to down. Okay, so by the help of inlet valve, fresh air comes, and by the exhaust valve, hot exhaust gas goes out. What is coming inside through the inlet valve? Through the inlet valve, in a petrol engine, fresh air comes. In a diesel engine, please listen. In a petrol engine, air and petrol mixture comes in inside the cylinder. Air and a petrol mixture in a vaporization form comes inside the cylinder in a petrol engine. But in a diesel engine, what is coming inside? In a diesel engine, only air is coming inside the cylinder through the inlet valve. So through the inlet valve in a petrol engine, air and petrol mixture comes. Petrol comes in a vaporization form or in a vapor form inside the cylinder. In which stroke engine? In petrol engine. But in a diesel engine, what is coming? Only air is coming inside the cylinder. This is suction stroke. Suction stroke for petrol engine is different things coming. Diesel engine is different thing coming. For diesel engine, only air is coming through the inlet valve. For a petrol engine, air and petrol mixture is coming inside the cylinder. Okay, and vaporized form coming. Vaporized form means in a vapor form. Petrol change to vapor form and come mix with air and comes inside the cylinder. This is a inlet valve. This gate open. Okay, this inlet valve, first inlet valve is open. See, inlet valve is opening. Then piston is moving down. Okay, and exhaust valve is closed. This is suction stroke. Now let's come to compression stroke. Compression stroke, both the valve is closed. Both the valve is closed. What is happening? Piston is moving from down to top. What is happening? Piston is moving from down to top. Okay, see, piston is moving top. This is compression stroke. Compression stroke, what is happening? Piston is moving from down to top. If you can't understand, again I am showing you. See, piston is moving up. This is compression stroke. In a compression stroke, piston is moving from down to top. Okay, and both the valves are closed. So what is happening in suction stroke? Piston is moving from top to down. What is happening in compression stroke? Piston is moving from bottom to top, and both the valve is closed in compression stroke, but inlet valve is open in suction stroke. What is coming inside the cylinder? In case of petrol engine, petrol and air mixture. What is coming inside the cylinder in diesel engine? Only air is coming. Okay. See, piston is moving up. So this is compression stroke. Okay. I hope you all are enjoying. Now, expansion stroke. What is happening in expansion stroke? Here, combustion is taking place. Expansion or power stroke. Sometimes they say it expansion or power stroke. So here combustion is taking place. In expansion or power stroke, combustion takes place. So how both the valves are closed. In expansion or power stroke, both the valves are closed. Okay. So in expansion and combustion takes place. How combustion takes place? In case of petrol engine, spark plug is there. That spark plug burns petrol and air mixture or vaporized form petrol and air mixture combination are burnt by the help of spark plug. In diesel engine, there is fuel injector. Fuel injector is there through where diesel comes, and that diesel comes get burned due to very high temperature air inside, and combustion takes place. Again, I am explaining. In petrol engine, vaporized combustion takes place. How vaporized combustion takes place? Due to the help of spark plug. Spark plug is there. That spark plug gives spark to petrol and air mixture. Okay. And in diesel engine, what is there? Fuel injector is there. Through the fuel injector, diesel comes inside the cylinder and gets burnt because air is very hot. Due to this reason, spot combustion takes place. What is spot combustion? Small combustion takes place, which combine together and generate very high temperature to push the piston downwards. So what I am telling you, diesel and petrol combustions, diesel engine are both different. Diesel engine, how combustion takes place, when I will explain you diesel and petrol engine, that time you will come to know more properly about the combustion. But now you at least try to have general idea. In diesel engine, how combustion takes place? In diesel engine, spot combustion takes place. What is spot combustion? Spot combustion means diesel is coming out through the fuel injector in small droplets that is mixed with the hot air and getting burnt by its own. Diesel is getting burnt by its own. That is known as also as auto ignition. What is happening? Diesel is getting burnt by its own. That is also known as auto ignition. But in petrol engine, what is happening? Petrol engine combustion is taking place because petrol and air mixture is there and you are giving spark, and that spark is burning the petrol and air mixture. That is known as diesel engine. So spot combustion takes place in diesel engine. But here spark ignition engine, spark comes and that spark burnt the petrol and air mixture. Petrol will be in vaporized form and petrol and air mixture gets burnt, and due to this reason combustion takes place. So in diesel and petrol combustion, both are different. Diesel engine, what is coming inside the cylinder? Diesel is coming inside the cylinder. From where? From fuel injector. In petrol engine, how petrol is getting burned? Petrol is getting burned because petrol and air mixture is already present inside the cylinder, and spark plug gives spark and burn the petrol and air mixture. Okay, so these are the both difference between diesel engine combustion and petrol engine combustion. Expansion or power stroke means combustion takes place and piston is pushed downward. Expansion or power stroke means combustion takes place and piston is pushed downwards. How combustion takes place in petrol engine? Because petrol and air mixture is there, spark plug gives spark and get burnt, which push the piston downward. How piston is pushed by diesel engine? That spot combustion takes place. Spot combustion means many places, small combustion, like small combustion is taking place in many places. Small spark is generated due to burning of due to automatic burning of the diesel, because small droplets is getting burnt, and that is generating very high temperature, which is pushing the piston downwards. So piston is pushed downwards. See, the piston is going downwards. In expansion or power stroke, what is happening? Piston is going downwards. What is happening in expansion and power stroke? Piston is going downward. As you can see, in expansion or power stroke, piston is moved downwards. Expansion or power stroke, piston is moved downwards. Okay, so what is happening in expansion or power stroke? Expansion or power stroke, piston is moving downwards. Okay, so this is happening in expansion and power stroke. So suction, compression, expansion or power, and another stroke is exhaust stroke. What is happening in exhaust? This is, see, expansion or power stroke, where piston is moved downwards. Okay, see, piston is going downwards. How piston is moving downward? Combustion takes place. Due to combustion, what is how burning is taking place in petrol engine? I again and again explained you by the help of spark plug. How combustion takes place in diesel engine? By the help of fuel injector. Diesel comes and diesel gets burnt because in compression both the valves are closed, so the air inside the cylinder gets very heated up, and due to which combustion takes place. Now, so exhaust stroke. What is happening in exhaust stroke? Exhaust valve opens and piston moves downwards. What is happening? Exhaust valve is opening and piston moves up. That is exhaust stroke. Okay, see, piston is going up. This is exhaust stroke. What is happening in exhaust stroke? Exhaust valve is opening and piston goes upward. This is exhaust stroke. Means what is exhaust valve is opening and piston is moving upward. This is exhaust stroke. Okay, exhaust stroke means what is happening? Exhaust valve is opening and piston is moving upward. This is known as exhaust stroke. Okay, so exhaust valve gets open, that is exhaust stroke. So which time both the valves are closed? Compression stroke, both the valves are closed, and power stroke, both the valves are closed. Okay, in suction stroke, inlet valve is open, outlet valve is closed. Compression stroke, both the valve, inlet and exhaust valve is closed. Expansion or power stroke, both the valves are closed. Exhaust stroke, exhaust valve opens. Movement of piston in suction stroke, piston moves from top to bottom. In compression stroke, from bottom to top. Expansion or power stroke, from top to bottom. Exhaust stroke, from bottom to top. So these are the strokes which normally takes place. Suction stroke, what from where to where piston is moving? From top to bottom. Compression stroke, from bottom to top. Expansion or power stroke, from top to bottom. Exhaust stroke, from bottom to top. So these are the stroke which normally takes place. Okay. So I'm thinking that again I will show you this exhaust valve is opening. Okay, and now I will explain you about two-stroke engine. In two-stroke engines, please remember, piston moves two times, one time up, one time down. That's all. Piston is, when it is moving up, what is happening in two-stroke engine? When it is moving up, here inlet port, through the port, the fresh air comes. Okay, through this inlet port, petrol and air mixture comes. Okay, petrol and air mixture comes through this inlet port. Okay, and it where is the inlet port is located? It is located beside the crankcase. So the inlet port, petrol and air mixture comes and it travels like this and it enters through the transfer port and it goes inside the cylinder. So suction is taking place, piston moves up and it covers this exhaust port. So the air gets compressed. Petrol and air mixture gets compressed. Spark plug gives spark, combustion takes place. So what is happening in two-stroke engine? How combustion takes place? In two-stroke engines, there are two times piston is moving up and down. How piston is moving in two-stroke engine? See, suction and compression. In suction and compression, what is happening? Piston moves up. So piston is moving up in suction and when the piston comes down, that is expansion and exhaust. Okay, in expansion and exhaust, what is happening? Piston is coming down. And what is happening in suction and compression? Piston moving up. Okay, so these are the things which are happening. Okay, expansion and exhaust, piston is moving down, and suction and compression, piston is moving up. So what is happening? When the piston moves up, the air comes, air and petrol mixture comes here. See this yellow color, the air and petrol mixture comes up. The piston is moving up. So air and petrol mixture comes up inside. So piston is moving up, air and petrol mixture comes. So here two things are taking place. Piston is moving up, that is compression. So the air and petrol mixture which is there on top, the piston is compressing, and here it is suction also. Here inlet port opens and what is suction is taking place. So when the piston is moving up, that time two strokes are taking place together, suction and compression. How it suction and compression? Because when the piston is moving up, this inlet port opens and air and petrol mixture enters, and that is located, this inlet port is located beside the crankcase. So air and petrol mixture comes inside, and that air and petrol mixture, when the piston moves up, that air and petrol mixture again goes beside this top of the cylinder. Okay, on the top of the cylinder, this air and petrol mixture goes and it get burnt. So what is happening? These are all taking place. So everything you can understand if I say you what is happening when the thing is that when the piston is moving up. Okay, suppose piston is moving up, in that time only inlet port opens and air and petrol mixture enters the cylinder, this yellow color, and it goes through the crankcase and it enters by the help of this transfer port inside the cylinder. So combustion takes place. After combustion, piston is moved down. So by the help of exhaust port, the hot exhaust gas goes out. So here two things are taking together. Okay, this is happening. Here two things are happening together. Here suction and compression takes place when piston moves up. Expansion and exhaust takes place when piston moves down. Two things takes together. Suction and compression takes place when piston move up. Expansion and exhaust takes place when piston moves down. So due to these reasons, this stroke is known as two stroke. Two stroke means two time, one time up, one time down. What stroke happening? Suction and compression when the piston moves up. When the piston comes down, expansion and exhaust. How expansion takes place? Expansion, the volume is increasing because piston moves down. So volume inside the cylinder is increasing, and exhaust means through the exhaust port the gases goes out. Once the piston comes down, the exhaust port gets open and the gases goes out. So these are the things which are happening. Suction and compression, expansion and exhaust. Expansion and exhaust down, suction and compression up. Okay. Now two-stroke engines. In two-stroke engines, suction and compression takes place when piston moves up. Again and again I told you, when piston is moving up, suction and piston is moving up. Okay, suction and compression takes place. This is piston. As it moves up, suction and compression is taking place. So in two-stroke engine, crankshaft rotates, suction and compression takes place when piston moves up. See, piston moves up, suction and compression takes place. So what is suction? Where you are taking inside the cylinder. Okay, what is compression? Where you are compressing or decreasing the volume, increasing the pressure, increasing the temperature. Compression means what? Decreasing the volume, increasing the pressure, increasing the temperature. How you are decreasing the volume? By moving the piston up. So as you move, piston is moving up and up, the volume inside the cylinder gets decreased. How? When expansion takes place? When piston moves down. Expansion means what? Opposite. Volume increases, pressure decreases, temperature decreases. Compression means what? Volume decreases, pressure increases, temperature increases. How volume is decreasing? Piston is going up, up, up. As piston is, as you can see, so the area inside the cylinder is getting decreased. Okay, so here in two-stroke, suction and compression takes place one time, expansion and exhaust takes place another time. See, this crankshaft also is rotating. Okay, so these are all two-stroke. So piston is going up. See, again two-stroke engine, suction and compression, piston moves up. Okay, this is suction and compression. Okay, one time when piston moves up in two-stroke, suction and compression takes place. Okay, and crankshaft also rotates. Okay, and expansion and exhaust takes place when piston moves downward. See, my dear, when piston moves downward, that time expansion and exhaust takes place. Compression, opposite of compression is expansion. When volume increases, pressure decreases, temperature decreases. Why? How volume is decreasing? When the piston moving downward. See, piston is moving downward. So on top, volume is increasing. Yes or not? Expansion means volume increases, pressure decreases, temperature decreases. So this is expansion or power stroke and exhaust. Exhaust stroke means exhaust port is will open and hot exhaust gas goes out. So my dear, these are the things which are taking place. Okay. So these are the things which are taking place in the two-stroke and four-stroke diesel engine. Okay, this is crankshaft is rotating. So I hope you all understand. In a short summary, I will again show you whatever I taught you. In a short summary, I will try to explain you. Okay. See, when final state is equal to initial state, after sequential process, that is known as cycle. Here it is showing that when final state is equal to initial state, after cycle is done in petrol and engine theoretically. In petrol engine, we draw Otto cycle. In diesel engine, we draw diesel cycle. For high speed diesel engine, we draw dual cycle. So what is cycle? When final state is equal to initial state. Okay. And for Otto cycle and diesel cycle is taking place. Okay. So what is happening? Otto cycle and diesel cycle are internally reversible. That means no heat losses from system to surrounding or from surrounding to the system. I told you year standard cycle, we assume here only as the working fluid. Okay, only here is we are assuming as the working fluid. See, cycle is drawn to analyze petrol and diesel engine theoretically. And Otto cycle or diesel cycle is internally reversible. What is the meaning of internally reversible? That means there is no losses taking place inside the cylinder, like friction or heat losses from the system to the surrounding or from the surrounding to the system. Practically, what is happening? Practically, due to chemical reaction, what is happening practically? Practically, due to chemical reaction, heat is getting generated. But theoretically, what is happening? Practically, heat is getting generated due to chemical reaction. Theoretically, practical and theoretical both are different. Practically, chemical reactions, heat is generated in IC engine. But in the theoretical in-year standard cycle, we assume we take heat from high temperature reservoir and reject heat to low temperature reservoir. Theoretically, we are thinking like this. What we are thinking? We are taking heat from high temperature reservoir and we are rejecting heat to low temperature reservoir. This is the thing which we are assuming theoretically. Practically, we are thinking different. Practically and theoretically both are different. The same thing is written. Practically due to chemical reaction, heat generated in IC engine. But theoretically in the year standard cycle, we assume we take heat from high temperature reservoir and reject heat to low temperature reservoir. This is 4-stroke engine. This is 2-stroke engine. I told you in 2-stroke engine, there is no valve, there is port. So in 2-stroke engine, there are holes. There is no valve, there is holes. Okay, please don't forget. In 2-stroke engine, piston moves 2 times up and down. In 4-stroke engine, piston moves 4 times up and down. In 2-stroke engine, crankshaft rotate 1 time. In 4-stroke engine, crankshaft rotate 2 times. And another difference, in 4-stroke engine, there are valve. In 2-stroke engine, there will be no valve, there will be port. What is port? Port is hole. You can think there is when you feed the window, before you feed the window in your house, there will be a hole. Like that same hole will be there in the cylinder. That is port, through where petrol and air mixture comes, or through where hot exhaust gas goes out, or through where the air comes and hot exhaust gas goes out in diesel engine. So port is a hole. Please remember, port is a hole. Port will be there in 2-stroke engine and valve will be there in 4-stroke engine. In 2-stroke engine, crankshaft rotates 1 time. In 4-stroke engine, crankshaft rotates 2 times. In 2-stroke engine, piston moves 2 times up and down. And 4-stroke engine, 1 time up, 1 time down. In 4-stroke engine, 4 times piston moves up and down. 1 time up, 1 time down, 1 time up, 1 time down. So double 2 for that into 2 if you do, that is 4-stroke engine. See, I already explained you all the strokes. That is also written here. Okay, this is four-stroke engine. Four-stroke engines, piston moves up and down. Suction means piston moves up and down. Okay, that is the thing. Moves up and down. Compression means piston moves down to top. Up and down, suction. Compression means piston moves down to up. That is compression. Expansion again from top to down. Okay, that is expansion. Exhaust means piston moves again from bottom to top. But what happens in two-stroke engine? Suction and compression takes place when piston moves up. Valve beside crankcase open. Either there will be valve or there will be port. Some cases there will be valve, some cases there will be port. It opens, and through the help of which fresh petrol and air mixture comes. And expansion exhaust stroke, what is happening? Piston is moving down. Okay, these are the difference between two-stroke and four-stroke engines. So I hope you all understand whatever I taught you all. Hope you all are very clear. Okay, so two-stroke engines, two-time piston moves up and down. So I expect you all are clear. Okay, whatever you have seen, I will try to show you again the video. This time I will not explain, just you see it and try to understand. And if you are having any doubt, you just ask me in the comment box. I hope everybody, you all are clear. And I also very thankful to all my respected faculties like Hari sir, Thatoi sir, Dr. Vijendra, Dr. Shibham, and all the respected faculties due to all the lecture videos which I am given in past or giving now. For all those reasons, I am thankful to them. And